Good morning and welcome to a video on long division, which I think is everyone's favorite topic. So before we start, I'm going to remind you of the long division that you learned about in maybe third or fourth grade. And you're going to see that the algorithm for doing this in pre-calculus is exactly the same. So let's say I had 371 divided by 4. All right, and let's actually perform the long division. So I have 4 and I want to see how many times it goes into 371, okay? Really quickly, you remember that you're going to look at 4 and you're going to look at 37 and say how many times does 4 go into 37? And you're going to say, oh, that's 9 times, right? And you're going to put the 9 here above the 7. Then you're going to multiply 9 times 4 and you're going to get 36. Then you're going to subtract, okay? So hopefully this is looking familiar and you're like, oh yeah, I remember this. And then you're going to subtract, so you're going to get 11. Okay, and I just brought down that 1. Okay, and then 4 goes into 11 how many times? 2. Then 2 times 4 is 8. 11 minus 8 is 3. And I'm done because 4 is too big to fit into 3. So I have 92 with a remainder of 3. Okay, so let's just talk about some of the parts of this, right? So 4, remember, is called my divisor. 371 is called my dividend. 92, I'm running out of room here. So 92 is called my quotient. And 3 is my remainder. So let me write that over here. And importantly, right, if I look at it as 371 over 4, remember this is just an improper fraction. Basically what I did by using long division is I converted it to a mixed number. So I know that that's the same as 92 and 3/4. Okay, so this mixed number is equivalent to the improper fraction. And if I wanted to take the mixed number, I could do 4 times 92 and then add the 3 and I'd get the same thing. So these are equivalent mathematically. One is an improper fraction, one is a mixed number, but that concept is going to apply to polynomials. So now let's take a more complicated example and let's just make sure that we remember this algorithm. Okay, so it's literally going to be the exact same thing. I'm going to do the same process, except I'm going to have variables. All right, so let's erase and let's come up with something else. So let's say we had, let's get a good example here. Let's say I had x to the 4th minus 4x cubed plus 3x squared plus 8x minus 16 divided by x squared minus x minus 4. Okay, so that's a super complicated version of what you did in third grade. And so what I'm going to do is I'm going to do the same thing. So x squared minus x minus 4 is going to be my divisor. And I'm going to have x to the 4th minus 4x cubed plus 3x squared plus 8x minus 16 as my dividend, and then I'm going to get the quotient, and there may or may not be a remainder. So same rules apply. You're going to look at just the x squared, and you're going to say to yourself, how many times does that go into x to the 4th? I only look at the first 2 terms. Or you could say x squared times what gives me x to the 4th? Well, that will be x squared, so I'm going to put that here. Then you're going to take the x squared and multiply this times every term in the divisor. X squared times x squared is x to the 4th. X squared times negative x is negative x cubed. X squared times negative 4 is negative 4x squared. You're going to subtract just like you did before. Now I just leave the minus sign out here because I think it's going to be too convoluted if I distribute it. But let's just do it in our head. So like the x to the 4th cancel. This is positive. This becomes negative 3x cubed, right? Because I'm adding those together. This becomes plus 7x squared, and I'm going to bring down the next term, which is the plus 8x. Okay, now you're asking yourself, how many times does x squared go into negative 3x cubed? Or you can say x squared times what gives me negative 3x cubed? And the answer to that is negative 3x, okay? So I'm going to take negative 3x and multiply that by each term in the divisor. Negative 3x times x squared is negative 3x cubed. Negative 3x times negative x is positive 3x squared. Negative 3x times negative 4 is plus 12x. And I'm going to subtract just like I did before. So just be careful with your minus signs, and I always keep this out of the parentheses. So if I were to distribute, the negative 3x and the positive 3x cancel. That's really negative 3x squared, so I have 4x squared. This is going to be minus 4x, and I'm going to bring down the negative 16. And I'm going to repeat. I'm going to ask myself, x squared times what gives me positive 4x squared? And the answer is plus 4. Okay, multiply 4 times every term in the divisor. That gives me 4x squared minus 4x minus 16. And if I subtract, what do you know? I have a remainder of 0, which just means that x squared minus x minus 4 is a factor of the polynomial. So I hope that helped a little bit with the long division. And you could really just say then that this is equal to, when I divide it, x squared, let's see if you can see that, minus 3x plus 4. In this particular case, there is no remainder. Now, just a quick note, I don't know if I mentioned this in my last video, but most people really don't like long division and they avoid it at all costs, which I get it, it's understandable. But you need long division if your divisor is a quadratic or higher, right? If your divisor is linear, right? Like, I don't know, let's say you had x minus 1 as your divisor. Well, then if you have a linear divisor, you can use synthetic division. So you only need long division because you can't use synthetic division unless you have a linear factor. Like, you can't use synthetic division with a squared term. So it is necessary for these cases where your divisor is quadratic or higher. I hope that helped, and in the next video, we're going to talk about rational roots and we're going to talk about imaginary roots.